Now that we've seen the dynamic dice rolling animation, let's take a look at the script that actually accomplishes that task. Now, some of the code, in fact a lot of the code that's in this script, I've already presented to you in detail in the preceding lessons Intro to Data Science section, so I won't spend a whole lot of time on that code that we've already discussed in detail, but I will summarize that code and focus on the new features in this script. Now, as we've done with each of the scripts we've presented, we do have a comment to just indicate the name of the file in which you can find the script, and we do have a doc string that describes the purpose of the script as well. Now, we've seen some of these import statements previously. The first one is new. From the Matplotlib module, we're going to import one of its submodules or packages, if you will, called animation. So there's a matplotlib.animation module that contains the animation capabilities of Matplotlib, just like there's the matplotlib.pyplot module that contains basic plotting capabilities for Matplotlib. So in the animation package is where we're going to find the func animation class that we're going to use to create the dynamic animation in this example. Now, in the previous Intro to Data Science section, when we first introduced visualization, we had this import statement that imported matplotlib.pyplot as PLT, and we'll use that once again in this example, and we'll introduce some new features here as well. We, of course, have already looked at random number generation a couple of times, so we'll import the random module for that purpose. And previously in the Intro to Data Science section from the last lesson, we took a look at some Seaborn capabilities, which we will reuse here. So again, we're importing Seaborn as SNS. Now, another new feature that we're taking advantage of in this example is the sys module from the Python standard library. And in particular, this module contains a list that represents the strings of information that are passed into an application as command line arguments. So if I switch back over to my terminal window for a moment here, you can see that when we invoked the script, we had some command line arguments. In fact, the script is actually the first element of the list. The name, I should say, of the script is the first element of this list, which is known as argv. ARGV, that actually comes from the C programming language where it originally meant argument vector. But that list contains a list of strings that has as its element 0 the name of the script that you executed, as its element 1 whatever comes next in the command line, so in this case it would be the string 6000, and then as its element 2 the string 1, and similarly in this next call to the script we would have the script name as the first element, the number 10,000 as a string in the second element, and 600 in the third element of that list. So it's always going to bring in those command line arguments as strings, and therefore if we want to use them as numeric values, which is how we use them in this script, we have to actually convert them from strings to integers by casting them, as we've demonstrated previously. So let's switch back over to the script, and instead of going right into the update method, which I'll talk about momentarily, let's jump down to the bottom of the script here and talk about the other standalone statements. In fact, you know what? Let's start from the top and just mention one other thing first. When you load up a script, Python executes the statements in that script top to bottom by default. So Python is going to execute the import declarations one at a time. It's going to execute the definition of the function update, meaning create the function in memory. Remember, all functions in Python are objects, so it actually creates a function object that represents this code. Then it's going to come down here and execute the remaining statements in the script. Now in lines 30 and 31 of the script is where we are taking in the command line arguments and turning them into numeric values. And you'll notice I'm not doing any validity checking here. I am assuming that the user typed those command line arguments properly as numeric integer values, and also I'm assuming that we have 2 additional command line arguments separate from the name of the script. So the way that you access a command line argument is with the sysmodules argv list, and element number 1 represents the second command line argument, which is always the first item after the script name. So this is going to be the number of animation frames, and then the second argument after the script name is going to be the number of rolls that we intend to perform per frame of animation. Now, we demonstrated line 33 in the previous Intro to Data Science section. This just determines the style of grid that will be used, or I should say the style of the chart that will be used as we visualize the bar plot. And remember that white grid has a white background with some gray lines crossing it so that you can follow those lines to the y-axis and see what the magnitudes of the bars actually approximately represent. Now, this next statement is new. Here we are assigning to a variable called figure the result of the matplotlib.pyplot module's figure function call. Now, the figure function returns an object of a class named figure with a capital F, and a figure is literally the window in which the diagram is going to be displayed. So we are actually creating that window in advance this time, whereas back in the preceding Intro to Data Science section, rather than creating it ourselves, we let Seaborn create it for us if that window did not already exist. So that's one of the features that's nice about Seaborn, is the fact that it's capable of helping you out by creating the window automatically. So here we also supply an argument to the figure function call. This actually becomes the title bar string in that figure. So for example, this is the title bar string in my TextMate window that I'm currently looking at. So this would be the title bar string in the plot window that we display in this animation. Next up, we create a list called values, and we give it the values 1 through 6, 1 up to but not including 7, and these are actually just going to be used as the labels along the x-axis in the diagram, and these of course represent the face values for the die, 1 through 6. And finally, we also have a frequencies list here. We've used a notation of multiplying a list by 6 to create that list. So we have a 1-element list containing 0, and we say to repeat that 6 times, and what we wind up with is a list of 6 elements, each of which is 0 initially, and we'll count the die frequencies using that frequencies list. Now, the key piece of this example is lines 39 through 41. This is the piece that creates and then drives the animation. Using the animation module that we imported at the top of this script, we're accessing the func animation class and creating a func animation object that is capable of driving our animation. It is extremely important, in order for the animation to work, that you assign the result of creating this object to a variable in your script. If you do not, the animation will simply be thrown away and it will not execute. Now, you'll notice when we create the animation object, the func animation object, we have a whole bunch of arguments that we are supplying in this case. The first 2 arguments are absolutely required. You cannot have a func animation without telling it the figure object, the matplotlib figure object, in which the animated results will be displayed, and you must give it the name of some function that the func animation will call once per animation frame to dynamically update the diagram. Those 2 arguments are required, and so we supply those in the proper order. And in fact, if I take a moment just to jump over to the documentation for Matplotlib's func animation class, you can see this documentation at the matplotlib.org site. They have a nice search capability, so you can look for it quickly that way. Now, you'll notice that the first argument is the figure, the second argument is the function, and then they've got some other potential arguments, and let's talk about that a little bit here. So we're actually going to use the frames and fargs arguments and this kwargs parameter as well. So the frames argument is going to be some sequence of values where each value in the sequence will be passed into the function that you specify as its first argument. In our case, that is just going to help us determine how many animation frames to produce. So if you give this an integer value, basically what's going to happen is that's the number of frames it's going to create. But it doesn't have to be an integer value. It could be a sequence of values where each item in the sequence should be passed into the function that you supply as the second argument. We're also going to take advantage of the fargs argument, which allows you to specify a tuple of other arguments to pass to your function that you define. So we're going to pass in several different arguments. And then there are a whole bunch of keyword arguments that you can supply to func animation as well. And if you scroll down in here, they describe all the possible arguments that you're allowed to pass into this func animation object that you're creating. So we're going to use a few of these in our code, and I'll describe them in the source code itself. So in the func animation creation here, we are saying that we're not going to repeat this animation once it completes. We're also saying that the frames argument should receive number of frames, which is the integer representing the total number of frames to create. So again, if this is an integer, it's actually the equivalent of saying call the range function with that integer as an argument. It creates a sequence of integers that goes from 0 up to but not including the number you provide. Or let's say you had a list of values that you wanted to pass into the update function. In our case, you could actually provide a list there or some other sequence of values where one at a time they would be passed off on a frame by frame basis. The interval keyword argument simply specifies how much time is going to lapse between frames of the animation. The default is 200 milliseconds, but we've specified 33 here to try to get approximately 30 frames per second of animation. And then finally, the last argument we are supplying, fargs here, again is a tuple of 3 additional values that we would like to pass into our update function. We want to know how many rolls to produce per frame of the animation. We want to pass in that values list that we created back here at line 35. Again, those will be displayed along the x-axis so that we know what each bar represents. And we want to pass in that frequencies list, which is where we're going to keep track of the frequencies of all the dice that have been rolled so far. So our update function is actually going to receive 4 arguments. One that comes from this frames argument to the func animation, and the other 3 are going to come from this fargs argument to the func animation. Now, once this statement completes in lines 39 through 41, the func animation will immediately begin executing. However, until you actually display the figure on the screen, which is what plt.show does, you won't see anything. So it's important that we call plt.show so that we can now see the animation actually happening. So now that we've talked about creating the animation, and now that the animation is up and running, that's going to result in calls to the update function once every 33 milliseconds, and I'm going to say once every approximately 33 milliseconds, because the amount of work we do in the update function could affect whether it's capable of maintaining that level of performance of getting 30 frames per second. So under the assumption that it can handle that, what's going to happen is once per animation frame, once every 33 milliseconds, the update method will be called. It will receive the frame number automatically as the first argument, and again, that is going to come from this frames argument to the func animation. And then it will receive as its other arguments the number of rolls to perform per animation frame, the value of the faces list so that we can display the names of the faces along the x-axis, and the frequencies list where we keep track of all the die rolls. So in the process of updating the diagram for one animation frame, the first thing we're going to do is roll the die the specified number of times. And for every roll of the dice, we are going to pick a random number from 1 through 6. We're then going to subtract 1 from that to give us a number from 0 through 5, which happen to be the indices into the list frequencies, which has 6 elements in it. And then we're going to add 1 to that counter value. Next up, we're going to clear the original figure, whatever was already in there, and we're going to now create a new set of axes with a bar plot on it. And we've seen all of this code previously. So sns.barplot is going to create the bar plot for me. Setting the title on the axes will display a string above the bar plot, in this case showing me the total number of dice that have been rolled so far as well. We're going to set the X and Y axes labels so that we see die value along the bottom and frequency along the left. And we're going to scale the y-axis by 10% so that we can make sure we have enough room at the top of the diagram for the text that we're going to add in above those bars. And again, we also saw this loop in the previous Intro to Data Science section, where we are simply walking through on a bar-by-bar basis and determining where to place the text, formatting that text with the exact same formatting we showed you previously, and then adding a text object to the axes object above the bar at the specified X and Y coordinate. So the vast majority of the code that you're seeing here in the update method has simply been repackaged from that previous visualization example, which we did interactively, not as a script. And now we put it into the update method, or function rather, so that it could be executed once per animation frame. So from the moment we create that func animation, this function starts getting called, and now we are off and running with our animation. And by the way, we'll also use those same capabilities again in a subsequent lesson where we will demonstrate additional animation capabilities, as well as a concept in Python known as a generator function. We talked about generator expressions previously. Generator functions are like generator expressions, but you define them as functions and they can return values on demand, just like a generator expression.